Please welcome Ryan Chandler.
Hello, welcome to LARACON EU, and welcome to my talk, From Zero to Static Analysis Hero. Let's start off with a little bit about me, in case you don't know who I am. My name is Ryan. I'm a software engineer and recently joined the Laravel team, where I'm working on Forge, Vapor, Envoy. I think this is my third week full-time in the role, so it's all still very fresh. I'm from Essex in the UK. I don't expect you all to know where that is, so I typically just say it's right outside of London. If you want to follow me on Twitter /X or Blue Sky, you can find me using that handle. Or if you want to do some light reading while you eat lunch, you can visit my website where I publish blog posts and write about programming stuff. So, static analysis. Put your hands up. I can hardly see you, but put your hands up if you think you know what static analysis is. Okay, mixed bag. We've got a few aficionados here getting ready to fact check me. No pressure. So for those of you who don't know what it is already, I've come prepared with this wonderful statement from Wikipedia that says static analysis is the analysis of computer programs performed without executing them. Or to put it into simpler words, static analysis tells you things about code but doesn't actually run it. Now, when we say the words static analysis, most of us tend to think about PHP stan or SAM, but it's actually a generic term that covers quite a wide range of tools. And I actually like to describe the different types of tools with a scale, one that focuses on spice levels. Do we have any fans of spicy food? Anyone? Again, yeah, mixed bag, cool. So on one end of the spectrum, you've got your mild, sort of plainish levels of spice, things like syntax checkers. They make sure your PHP code is actually valid PHP code. Tools that count the number of lines of code in a project, or even documentation generators for your APIs or even your code. They're just looking at your code and figuring out what's what from doc blocks. These tools don't really get in the way. They don't make you sweat or panic. They do a really simple job, and they normally do it quite well. And then you move up the scales a little bit, and you get to your medium spice levels. You have things like linters. They do their job. They do slightly more than a regular syntax checker, telling you about the casing of method names or the placement of your braces, tabs versus spaces, like silly things that nobody ever argues about. And then you've got your code formatters that take some of that information and basically fix it for you. And they're good. They typically stay out of the way. And then you have your traditional static analyzers like PHP stan or SAM running in easy mode. They're not doing a lot, just the basics. But all of these types of tools are still relatively simple. There's a bit more to it when it comes to configuring them, a little bit of bike shedding with your team about whether variables should be snake-cased or camel-cased. But you talk about it, come to a decision, and then forget about it until someone new joins the team and questions everything. But for the most part, they put in a good shift, and you never really have to worry about them unless there's something wrong. And then the very end of the scale is where you find the hot, spicy, and for most people, hard to manage category of tools. So these are things like PHP stan or SAM, but running at really high or max levels. Every single opinion or feature that the tool has will be enforced on your code. And you'll either really enjoy it, like you spice lovers, and have a great time looking at infinite type errors, or it will slowly drive you insane and you'll start to suffer. And then you get humans, us, because we are just biological static analyzers. You know, we write code, but we spend more time reading it and figuring out what it does. And we're also incredibly opinionated for the most part, just like PHP stan or SAM when it comes to programming, whether we've got our own ideas of what code should look like or ideas that we've picked up from others. Now, I'm not a psychology professional. This isn't a psychology presentation, so we'll take humans out for now. But it's a good thing to keep in mind as you listen to this talk, because you'll notice that a lot of the stuff that static analyzers are capable of will actually negate the human part of the question. So we've got our 3 spice levels, and I think most people can relate to the emojis. Your mild spice tools like syntax checkers, they're easily manageable, no struggles, they stay out of the way. Then the medium spice tools, you're still pretty happy, you're comfortable, you're not fidgeting at the dinner table, but in some cases you might think it's a little bit too much. And then the spicy ones, where the majority of people would rather avoid them because they tend to inflict pain. You're constantly battling error messages, trying your hardest to suppress them, but they get a second wind and they come back to bite you. So I've only got like 25 minutes for this talk, so I want to narrow down the context a little bit, because I could be up here for hours talking about this, and focus on static analysis that falls into the medium spicy range, since I think that's where most developers will see the gains and benefits. Specifically, I want to talk to you about conformance. Now, everything I talk about is going to be focused around PHP Stan, since I'm pretty sure this is the most popular static analyzer in the ecosystem, and some of you are probably already using it. So what do I mean by conformance? Well, as your code executes, the PHP engine is basically going through a long list of things that need to be checked, a bit like SpongeBob's list here. And this is what we call runtime or dynamic analysis. So these runtime checks are designed to prevent these sort of things. So using a class that doesn't exist, or calling a method that doesn't exist. Could be something simple, like a spelling error. We can have a method or function where we've given the wrong number of arguments, or even the wrong type of argument. And these errors can actually have a huge impact on your project or product if they make it all the way to production. Your users are going to see 500 server error when they try to do anything, which normally leads to more support requests, which could ultimately end up with a loss of income because your users aren't going to be too happy with you. But the exact checks that PHP performs at runtime are the exact same checks that a static analyzer like PHP Stan performs, but the only difference is PHP Stan does it before and without running your code. So some of you might be saying, well, PHP Storm does that, or VS Code does that, and you're not wrong. Those tools can do some of, or most of those checks, but you're assuming that all IDEs are created equally. Think of the poor developers who can't figure out how to quit Vim, Sorry, Vim users, if there are any. I'm sure you would have said something. But different IDEs and developers use different configs. And it's quite hard to get those different editors to behave exactly the same when they're built fundamentally different. You could force everyone on your team to use the same editor to combat that, but then you've got the opinionated humans in the equation again. Everyone has their own personal preference. Another group of you might also be thinking, well, I've got tests that can catch these problems. And tests are great, but they normally are written to prove correctness rather than incorrectness. So making sure that a method returns the right value when given the right arguments, that sort of thing. For your tests to actually act like a static analyzer, you need 100% test coverage, which the majority of projects won't have and shouldn't have. Writing tests to cover every single scenario or code pathway is a huge time investment, and honestly, 99% of the time, it's not worth it. What's most important to us is that our code is doing what we expect to happen, what most of us will call the happy path. So a tool like PHP Stan should work in addition to your IDE and tests. It does the same checks that PHP does, just without running your code. It's capable of inspecting and analyzing your entire code base all at once. You could do this yourself, but you'd have to go through every file and every dependency and remember those details as you go along. And I mentioned that not all IDEs are created equally. If you have a separate, dedicated static analyzer, like PHP Stan, you only need one config file, and that same config is used by all developers on your team, regardless of their editor or IDE. But more importantly, a static analyzer doesn't need to be executed manually. You can, just like your tests, make it part of your commit hooks or your CI build pipelines. So if it fails and produces an error, you can prevent a problematic PR from being merged in the first place. But static analyzers aren't just about conforming to PHP set rules. They're also about flexibility. and being able to customize the tools to follow your own personal rules. Things like making all classes final by default. Anyone do that in here? Oh, yeah, that's a small crowd. Injecting class dependencies instead of using facades. Injection over facades. Yeah, okay, yeah, fair enough. Nothing too controversial. The problem with these sort of checks is that unless you're incredibly consistent when you're writing or reviewing code, they often go unnoticed. So by adding PHP Stan or a similar tool to your belt, you can go back to focusing on the more important stuff like architecture or design decisions in the code. The tool essentially becomes a team member. It takes that load off of you and handles it in the background. But Ryan, how do we do these things? Well, I'm glad you asked, thank you. We're going to get a little bit more technical, but hopefully you can follow along and learn something new. So to customize things to our liking, we need to understand how PHP Stan itself performs its analysis, or more specifically, how it processes your code. The first step in the process is taking your code, your PHP files, and sending it through a parser. Now, the parser is the thing that's responsible for taking a string of spaghetti characters that otherwise have no meaning and turning them into something meaningful. In this context, something meaningful is the AST, or abstract syntax tree. So this is a structured representation of your code. So let's imagine a class in our project called foo. Hopefully that's big enough. It's got a deprecated attribute, something that was recently added to PHP, a foo property, a constructor, and a save method. Pretty simple. When that piece of code is sent through the parser, the AST that's produced might look something like this. So we've got a class statement node. That's the top level node in this case. And that node itself forms like a small tree where each branch in the tree is another node. So you'll have a node for the class name, since it's meaningful. You might have a list of nodes for the properties and methods, and then another node for the attribute list. And this tree-like structure is the entire basis of the AST, abstract syntax tree. Every single thing that is meaningful in your code has a dedicated AST node, and those nodes can be connected. So once you've got that AST, it's been generated, PHP Stan can then start to traverse it. So this is a process where you start from the root node. That could be a class statement, a function statement, or an expression, and you visit each node in the subtree. You work your way down the branches. So going back to the AST for our example foo class, we start at the top with a class statement. You'd see that it has a name child node, so you'd visit that node and process it. You might then process the attribute list, and then you can go through each of the class member nodes too, so the constructor, then the save method, and finally the name property. Now, what tools like PHP Stan do during this build process is build up a repository of information so that it can be referenced later on or when actually performing the analysis. Every class, interface, enum, function, method, property, trait, everything in your project will be stored somewhere in this repository. PHP Stan then adds like a reflection API on top so that you can query for certain things, like retrieving a particular class or getting a function so that you can look up its return type, that sort of thing. Then when you configure PHP Stan, you normally define a list of paths that it needs to analyze. So this will be your application code, config, database migrations, everything that's important in your project. And then it repeats those steps and traverses every PHP file found in those paths. The traversal step here is slightly modified. So instead of looking for classes or functions, instead it tries to apply analysis rules to the code. So this is where things like type checking and conformance checks take place. So now that we've got that out of the way, let's actually look at what it takes to write a custom PHP Stan rule. Let's write a rule that prevents you from calling the value helper in a Laravel project when you don't really need to. Does anyone know what the value helper is? No? Can I not see hands? That's cheating. If you're not familiar, which most of you aren't apparently, it's a small helper function provided by the framework that returns the value that is passed to it. Or if you provide a closure, it invokes that closure and will return the value that the closure returns. So in this instance, a string is passed through, so the function is just going to return that string. But in this case, we're passing through a closure, so it will call that closure and return the result of 1 plus 2, which is 3. Our custom PHP stand rule is going to tell you off for doing something like this. There's no need to call value here. Since we're not passing through a closure, we could just use the hello string directly. It could be a variable or a function call, but we don't need to call value. I'm going to do this live, so hopefully it all goes to plan. But I think it's nice for you to follow along as I actually write the code, instead of just reading it to you from a slide. So I'm going to need to change my display over quickly. There is a keyboard shortcut for this, but I cannot remember it. Are we mirroring? Perfect. All right. Let's get some notes here just to be safe. Cool. Right, so I've got more or less an empty Laravel project here. I've done 2 things. I've installed PHP stand already because I didn't want to rely on the Wi-Fi. That's when live coding goes wrong. And I've also added a value call. So if we go to Composer file, is this big enough for you? Can you see it, or do you want me to make it a bit bigger? Bit bigger. All right, no worries. Better? Bigger? Yeah, that'll do. Right. You'll have to zoom in later and watch it back. So we've got PHP stand here, version 2.1, so pretty much the latest. And we've also got a PHP stand.neon file, which is the configuration file. Now, I've pre-configured this. I've got all of the meaningful Laravel paths here, minus tests. You can put tests in there if you want. And I've set PHP stand to level 5, which is sort of like the mid-level. It does enough to be useful, but it's not too extreme that you're going to go crazy. And then if we head over to the console roots, I've got a command here called LARACON, and I'm echoing out the result of value hello. So we can actually go ahead and run this in the terminal, so PHP artisan LARACON, and we can see hello. So what we want to happen now is PHP stand to find that call to value and tell us that we shouldn't be calling value because it's pointless. It's not really doing anything. The first step there is going to be creating a new class. So I'm going to do this inside of app. We'll do PHP stand/rules, and I'm going to create a file. Let's call it unnecessary value call rule. Cool. So this is a PHP file. So we need to give it a namespace, which is going to be something like this. I've got some form of AI trying to help me out. I'm going to ignore it. We're going to need a class. So we'll call it unnecessary value call rule, if I can type. And we're going to implement an interface. So the exact interface here, oh wait, AI is helping out, is that one. So this interface is used by PHP stand internally. It needs us to implement 2 methods. The first one, AI is just better. It's just doing my job for me. It's getNodeType. So as I said, we're traversing the AST, and for every node in the AST, PHP stand is going to check to see if there are any rules that apply to that node. So in our case, we want to check function calls, which is the func call node. So that's our first method. We're saying we want this rule to apply to all function calls. We also need to add a process node method. Now this is going to accept 2 parameters, the first being a node from the PHP parser package, and the other one is a scope. And we need to return an array. Here's an example of my editor not working properly because it's not auto-completing the import for scope. So I'm going to add in an empty array here because I want to make sure that we've got this configured properly with PHP stand first before we start implementing our rule. So I'm going to head back over to PHP stand.neon. Neon is kind of like YAML. I think there are some differences, but for the most part it's the same. So I'm going to add a top-level key here called rules, and then using a hyphen, I'm going to put the fully qualified class name for our rule into here. So PHP stand rules, and we called it unnecessary value call rule, just like that. Okay, so I should be able to run vendor bin PHP stand, and I'm going to set the memory limit here to -1 so that we don't run out of memory. Let's make this apparently not very big. Cool, so we don't get any errors, which hopefully means our rule is configured properly. If it wasn't, PHP stand would tell us. So let's actually implement our rule. The first thing we need to do here is double check or triple check that what we've received is indeed a func call. So I'm going to do something really simple here and just say if node isn't an instance of func call, return an empty array. This is preventative. It shouldn't ever happen. But if something goes wrong in PHP stand, it's better to be safe than sorry. Now, if we head back to the console file here, hopefully you can see that fine side by side. We're looking for function calls to the value function. Now, the func call node itself has a name property. That's part of the AST. So we can grab the name by getting the name property. And name could be a couple of things. We could be calling a variable like this. We don't care about those here. So we want to make sure that name is an instance of name. So that's a PHP node, if it's not an instance of name. Or if name to string is not equal to value. Now, so let's close that window there. So if we're not calling a named function like value, or if the name of the function that we're calling isn't value, let's just return an empty array. We don't need to care about those ones. The next thing is the arguments. Since we're only interested in calls to value that aren't passing a closure, we're going to grab the arguments from the node. There's a getArgs method. If we're not passing through any args, so if it's an empty array, we'll return an empty array. We can't do anything with that. We don't have enough information. Otherwise, we should be able to grab the first argument. So that will be args0. Now, arg itself is actually an AST node. So to get the expression from that node, we need to access the value property. And if we hover here, you can see there's an expression. That's what we want. So if you remember back to the function signature, there's a scope parameter. Now, scope is a way for PHP stand to keep track of contextual stuff. So where we are in a PHP file, the variables that are defined, the class that we're in, the function that we're in even. So we can use that to infer the type of certain expressions. So in this case, I can say type is scope, get type, value. Now, PHP stand has an internal sort of type system. So what we could do here is say if type is not closure, but that doesn't really work well. If you think about it, you could have something that is closure or string. This is a union type. It is actually kind of compatible with closure. There are cases where it could be a closure or a string. So we can't just check if type is a closure or not. Instead, we actually need to see if it's compatible anywhere in that chain with closure. So what I'll say here is if type is super type of, it's a superhero type. I'm just going to refer back to my notes to make sure I don't get this wrong. Yeah, so if type is a super type of, and then we want to see if it's compatible with a closure. So we'll pass through closure type. I'm using fully qualified class names here just so that you can see things. And I'll break it across multiple lines if that works. There we go. So closure type itself is like a function. So we could pass arguments to it. For now, I'll pass an empty array of arguments. It also has a return type because it's like a function. I don't really care what the return type is, so I'm going to just say mixed type, since that is compatible with all types. And then we can call a method on this result. So I'll go back to when I said that you could have union types, so a closure or a string. The reason that we can't just say yes or no to that is because there is a middle ground. If it is a closure or a string, it might be a closure. So PHP Stan uses something called a trinary system. So yes, maybe, or no. Up until, I think it's level 6 in PHP Stan, it doesn't actually care whether it's yes or maybe. It treats them as the same thing. So I'm on level 5, I'm going to do the same thing. So if it's not compatible with a closure type, or no is false, we'll just return an empty array. So what we're saying here, it's not very readable, is it, like that? But if type is a super type of closure, is it compatible with the closure type in some way, shape, or form? If the answer to that is no, then we'll return an empty array. Otherwise, we know for a fact that it's something like a string, in which case we can return an error message. So we could just return a string here, but PHP Stan has a nice API for building rules. So we'll do rule error builder. We call a static method on this, and I'm going to say unnecessary call to value helper. So that's our error message. That's what will show up in the terminal. We need to tell PHP Stan where that's happening. So we'll do line, and the AST node has a get start line method. That's where in the file it starts. PHP Stan also has error identifiers. So instead of ignoring every single error, you can ignore specific ones. So I'll give this an identifier of custom, and let's go with unnecessary value call. And then we call the build method. So from the top, very quickly, we should have a function call. If we don't, we return. We should be calling a named function where the name is value. That function call should have some arguments, and the type of that argument should be something that's not compatible with a closure. If it isn't, then we produce an error message. So moment of truth, let's run this again. So vendor bin PHP Stan, and the memory limit set to -1. I have a syntax error somewhere. I'm missing a left parenthesis there. There, like that. So let's run again. You see it's analyzing the files. It found one error. PHP Stan types mixed type not found while analyzing file. Have I made a typo? I have, it should be type. Classic. I was really hoping this would go smoothly, like no issues, but there we go. Right, we've got an error message. So in root console.php, we have an unnecessary call to the value helper. So it's doing what we expect. And to triple check that, we can go back, and if we change this to a short closure, so a function that returns hello, and run that again, that error should go away, because PHP Stan knows that the thing that we're passing through to value is a closure. And that's basically it. This is a really simple case. You can obviously take this a lot further. And what I would actually recommend is, do I have to change my display back to stop mirroring? Yeah. There we go. What I would actually recommend is that you, A, check out Larastan. I discovered that Larastan actually has this rule built in. It's implemented slightly differently. It does a much better job at catching cases. But check out Larastan if you're using Laravel. I assume you are, you're here. It handles a lot of the nuances around like eloquent models and accessing model properties, your database casts, those sort of things. And if you're specifically interested in learning more about what you can do with PHP Stan's extension API, I would recommend you head over to the PHP Stan website. You'll find documentation on basically everything. It's very well written, very deep. So if you need something, you'll find it there. Hopefully you learned something new and can walk away from this talk with some cool ideas. If you want to come and chat with me over lunch, please feel free. I'll be more than happy to talk to you about this stuff. But yeah, thank you for listening. Thank you. What?
I have what?
Yeah.
Questions.
Go.
So, Niels is asking, do you install PHP Stan in every project?
Yeah, more or less. Unless it's like a proof of concept. Yeah, if it's a serious project, I would. I think it's one of those things where it's better to have it than not have it.
Makes sense.
It will help you in some way, shape, or form. Yeah.
Would you live without it, for example?
Yeah, because there's other tools, right? But if it's just PHP Stan specifically, you've got Psalm, which is implemented slightly differently, has different APIs. So, yeah, you could live without it. You could rely on other things,
But better have it than
exactly.
not.
Yeah.
Okay. Our dear friend, anonymous user, is asking, why don't you like Marmite?
I wonder who the anonymous user is. Just not for me.
It's not for you?
Not for me. Simple as.
Have you tried to sprinkle with the sprinkles that we have here in Amsterdam? Could be good.
Yeah.
The sugar sprinkles. Tastes like rainbow. Still enough?
I'll stick to what I know.
Okay.
Yeah.
Tough crowd.
Yeah.
Okay. Thank you so much for this talk.
Thank you.
Thank you, Ryan.